So waves. The first thing we need to know about waves is there are two types of waves. So there was what were the two types of waves? Anybody remember? Transverse and longitudinal. All right. Longitudinal were also known as compression waves. Okay, so what is a longitudinal, or so what does a transverse wave look like? Very good, Ethan. All right, so it looks like this. It waves up and down. Compression waves or longitudinal waves look slightly different. Okay, I was going to be impressed if you could do them. Compression waves look like this. They're a series of compression areas and rarefaction areas. Rarefactions where they're spread out, and compressions obviously where they're compressed. So that's how they work. They have areas of compression and rarefaction. Okay? And they're spread out, and it would continue on. Most of the time we represent longitudinal waves as transverse waves just because it's easier to talk about them like that. There is one formula for waves, and that is V is equal to lambda F. I think this should be the only formula you should need for this section. How do you calculate, all right, F? Frequency is something that gets y'all all the time. So I'm going to write it down again. Frequency is the number of cycles something happens, like the number of times something happens in a second. And the period is the number of seconds it takes a cycle to happen. All right, so those two things are inversely related to each other. Okay? If we have a wave, like so, if you need to calculate a wavelength, there are three ways to calculate a wavelength. Give me one way to calculate a wavelength. Trough to trough is a wavelength. So from here to here is a wavelength. What about another one? What's another one?
3 nodes.
3 nodes. 1, 2, 3 nodes. So from there to there is a wavelength. What's another one? Crest to crest is a wavelength. Okay, there you go. Three wavelengths. The distance from the midline to the top of the crest or the bottom of the trough, what's that known as?
Amplitude.
The amplitude. The amplitude is important because it tells us how much blank a wave has. Energy. Very good. On the ball, Dave. All right. So, yeah, he did tell me that. All right. So, that's what wavelength is. Amplitude is the energy that's held within the wave. That's how you find the wavelength. Let's see, is there anything else we need to talk about this? Crests, troughs, wavelengths. Oh, nodes and antinodes. What is a node used for? Or what is a node? What makes it a node? Place where it doesn't move. Amplitude, or sorry, the antinode is the place where there is maximum movement. Very good. Okay, so, got all that stuff down. That's basic wave characteristics. Anybody got any questions about basic wave characteristics? Don't stop it yet. All right, good. So, next up, we've got wave phenomenon. All right, so there were wave phenomenon. There were several different versions of wave phenomenon. They were reflection. There was reflection, refraction, diffraction, there's another action, or shun, polarization, and I think the Doppler effect is what you need to know probably. Yes.
On the 1 second, the test for calculus on there, but they said there's a section for physics 1. You have to answer 2 questions, or 2 answers for 1 question.
Yes, that's true. But it will say specifically, answer 2 questions. There are 2 answers.
What are they going to be asking?
What do you mean? It's just a regular multiple. There were questions like it on the problem set I gave y'all. You've got it. You've seen it. No, I mean, it's just like a normal question, though. It's just like, hey, it might be something like, list 2 characteristics of a wave, and there will be examples like amplitude and wavelength would be on there, and you would just bubble amplitude and wavelength. It's just going to be 2 answer choices. Yes.
Does the Doppler effect have a formula?
Does the Doppler effect have a what?
A formula.
It does. I'll get to that in just a second. All right, so reflection and refraction, diffraction and polarization. Reflection is what occurs when the wave is what? Bouncing off a surface. All right, refraction occurs when a wave does what? No, not quite. Refraction occurs when a wave enters a new medium.
Oh.
And the speed of the wave changes as it enters that new medium. Diffraction, when does it happen? When a wave bends around an object, that's known as diffraction. And typically, when it bends around an object, it will become misshapen. The quicker the frequency of the waves, the more the diffraction will be. Okay? And then, lastly, polarization. Polarization, anybody remember what that is? Yeah. It's whenever you limit the direction of a transverse wave to one direction. So sometimes transverse waves can be moving in all kinds of different ways. You put a polarized lens there, it can only move in one direction now. And then lastly, Doppler effect. The Doppler effect is whenever there's a perceived change in sound due to something moving towards or away from you. Okay? And I don't think, they'll probably give you this formula if it comes up, but it's like frequency prime, the frequency you hear, is equal to the frequency emitted times the speed of sound minus the speed of the object, or sorry, plus or minus the speed of the object, divided by the speed of sound. So if the object is going, faster, or sorry, if it's coming towards you, you add it. If it's going away from you, you subtract it, and you divide it by the speed of sound. So it's speed of sound plus or minus the speed of the object divided by the speed of sound. Notice that if the object is coming towards you, you would make it positive. So that means the number here would be greater than 1, which would make the heard frequency high. And if it's going away from you, it's negative. So the perceived frequency would be less than 1, and it would make it lower. Right? Does that make sense? Anybody got any questions before we move on? Questions about waves? All right.